Hi students, welcome to solving rational equations, but modeling and problem solving version. Okay, so what you have to do is you have to create your own rational equation from the given problem. Alright, so two friends take turns delivering newspapers. Andre takes 15 minutes to deliver when it's his turn, Larry takes 40 minutes. So they deliver individually. How long would it take to deliver a newspaper if they choose to work together? Okay, well let's set up a little bit of a grid here just to understand what's going on. Okay, so Andre, so we'll use that, and this is Larry. Okay, well, how much time would it take Andre, or how much work would he do if he had completed 1 minute of work? Well, if he had completed 1 minute of work, he would have completed 1/50th of the job. Right? Because it takes him 50 minutes to complete. So if he did 1 minute, he would have worked 1/50th. Well, Larry would have completed 1/40th of the job in that same minute. I'm trying to figure out, well, how many minutes does it take to complete the job? So I don't actually know how many minutes they're going to work together. Right? So I'm going to say X minutes. Okay, well, Andre would have completed X over 50 total. Right? So if he would have worked 10 minutes, Andre would have completed 10/50th of the job. If Larry would have worked 10 minutes, he would have worked 10/40th of the job. So same thing with Larry. Larry would have completed X over 40. And they've completed one job together, correct? So therefore what you have is X over 50. And you're going to add, that's what Andre did. Larry's going to do his job, X over 40. And the total is going to give us a total of one job. And just to identify the variable here, X is the total amount of minutes, to complete. Okay, so now we're just solving this equation. Fairly easy. You have a common denominator of 200. Okay, so this is 1540, so the common denominator is 200. So I'm going to take every fraction, and I'm going to multiply it by 200. And notice I have to also multiply the 1 by 200 just to balance out the equation. Okay, so, well, this 200 divided by 50 is 4. And 200 divided by 40 is 5. So what we have left is 4 times x plus 5 times x equals to 200. So you've got 9x equals to 200. Okay, and really the answer is simply 200 over 9. If you're wanting an actual exact value, and if you wanted a rounded answer, so I'm just going to round to 2 decimals, I'd say x is approximately equal to 22.22 minutes. Okay, so these are minutes, and this is minutes. Okay. Alright, so the following problem is going to be answered probably a little bit differently. Okay, so what we're going to do is we're going to travel from Winnipeg to Regina and return to Winnipeg. Alright, so the total distance of the trip is 1,100 kilometers. So basically it's 550 kilometers to Regina and then 550 kilometers back to Winnipeg. Okay, so we go to Winnipeg to Regina, and the return to Winnipeg from Regina is done through a blizzard. And so the average speed of both trips was a difference of 20 kilometers per hour. So we went a little slower coming back to Winnipeg because of the blizzard. So the total trip took us 13 hours. Find the average speed in each direction. Okay, well, I have an equation here from a physics course, if you haven't taken physics, or in grade 10 science, probably learned this before. Distance is equal to the speed times the time. Well, notice that I know the total trip, so I know the time. So I'm going to rewrite this as distance equals to speed, so s times t. And if I was to solve for time, I would have d over s equals to t. Well, I actually don't know s, right? I don't know the speed. I do know distance, and I do know time. Okay, so let's map this out a little bit. Winnipeg to Regina, and then we have Regina back to Winnipeg. Okay, well, let's say Winnipeg to Regina, we traveled at a velocity v, right? and our distance would have been 550 kilometers. And then on the way back, I would have traveled 550 kilometers again. However, my speed was lowered by 20, so I would do v minus 20. So again, we're going to state what our variable is. Let's call it v, and we're going to call this the speed from Winnipeg to Regina. Okay, so notice that the velocity from, or the speed from Regina to Winnipeg would just be v minus 20, because we said we were going 20 kilometers per hour less. Okay, well, let's set up this equation. Well, technically, my total time was 13 hours, so I would have traveled 13 hours, and my distance would have been broken up into two different velocities. So the first distance I would have traveled would be 550 kilometers, and that would have been at a velocity v, and then, again, distance 550 over a velocity of v minus 20. And there is the equation we're going to use to solve this problem. Okay, well, we're going to do exactly what we did in the past. We're going to find a lowest common denominator, and in this case it would be v times v minus 20. Hope you can spot that from the two factors here. So notice that we have non-permissible values. Okay, so v cannot equal to 0 and cannot equal to 20. I'm going to come back to that in a second once we finish the problem. Okay, so I'm going to multiply everything by v times v minus 20. So maybe I'll rewrite this. We got lots of room. Okay, we have v times v minus 20, and we multiply that by 13. I've got v times v minus 20, multiply that by 550 over v, plus v times v minus 20. So again, I'm just multiplying to eliminate the denominator, and I multiplied by our lowest common denominator. Okay, so let's get rid of the factors I can get rid of. The v's cancel out here. The v minus 20 cancels out here. So now I have 13v times v minus 20. So all I did was multiply the 13 and the v together. It's just rearrange the order, correct? And then here I have 550 times v minus 20. Again, I just rearranged the order. So 2 times 3 is the same thing as 3 times 2. So I just rearranged it in order just to be a little nicer to look at. And then here I have 550 times v, because the v minus 20 factor is gone. Okay, so again, we're going to kind of solve the problem the exact same way. We are going to just expand, right? Bring all the terms to one side, make it equal to 0 on one side. So let's do that. Okay, so we have 13v squared minus 260v, so that's distribution. And then minus 550v minus 1100. I think I'm missing a 0 in there. Yep, so 11,000. So we have 1 0, 2 zeros, and then 2 times 550 is 110. And then we have plus 550v. Okay, so I'm going to bring everything over to this side because it has 13v squared and it's positive already, so let's leave that here. No other v squareds in the equation. Okay, so now I have 1100v. We're going to subtract it. You end up with 1360v. And plus, because you're going to bring it over the other side, 11,000 equals 0. Okay, so I don't think you want to factor this. Even if you can, it'd probably be hard to do. So I think our best case scenario would just be to directly plug it into our quadratic formula. So v equals to negative 1360 plus or minus square root of b squared, which is negative 1360 squared, minus 4 times a times c, and all that is divided by 2 times a. Okay, I'm going to give you guys a second to plug that into your calculator. Okay, I would recommend you pause it and make sure you can figure this out with your calculator, how to do it properly. And these are the following solutions you should find. Alright, so I've got 95.78. So that should be a point here. And the other one should be 8.83. Okay, well, there's a problem with one of these two velocities. Think about the original problem. Notice that neither of these are the non-permissible values because the non-permissible values are 20 and 0. Okay, neither one of those are there. However, If you plugged in v equals 8.83 into this formula right here, you would have a negative velocity on the way back. So obviously the value of v has to be larger than 20, cannot be equal to 20. Okay, so v has to be larger than 20, which means that we are going to reject this solution because it is impossible. So the velocity on the way to Regina, our average speed was about 96 kilometers per hour, which means on the way back, our velocity would have been 95.78 minus 20, so about 76 kilometers per hour on the way back. So let's make sure we answer the problem. It's saying find the average speed in each direction. Okay, so that's what we want to find. So from Winnipeg to Regina, we had 95.78 kilometers per hour. And from Regina to Winnipeg, we had 20 less than that, so 75.78 kilometers per hour. Okay, that's it for this lesson. I'm sure your teacher is going to probably do a few more practice questions in class, but this is a good start. Good luck, students, and again, don't forget, ask your teacher if you have any questions.